Okay, this is atoms, isotopes, and ions. When we're talking about atoms, we kind of want to know what can an atom tell us? What kind of information can we get? So one of the first things we look at is the periodic table. Okay, and when you look at the periodic table, you're going to see a square similar to this with a number, a symbol, and then a number with a decimal. Okay. All right, so these are the three things you're going to see typically. Sometimes it'll have the name, but sometimes it won't. So this number at the top, this whole number, okay, this is going to be your atomic number. Okay, and your atomic number is going to be the number of protons and electrons in a neutral atom. Okay, so basically it's the number of protons, and it's the number of electrons when neutral. Okay, so that top number is going to tell you that. This symbol right here, this is your atomic symbol, okay, or your element symbol. We'll call it an element symbol. You'll see it written different ways, either element symbol or atomic symbol. The first letter is always capital, okay? So first letter, always capitalized. Okay, and then that's a good way to determine how many different elements are in a compound. Just count the number of capital letters, and that's how many different elements there are. Okay, this bottom number is going to be your atomic mass. Okay, it's going to be actually your average atomic mass. Okay, and what that is it takes the mass of all the isotopes and it takes their relative abundance into consideration, and they multiply all those numbers and add them all up and divide them, and then they get an average, which is what that number is. So it's the average atomic mass, okay, and it's the average number of protons plus neutrons. It's the average number of protons plus neutrons. Okay, so if we took, let's say we take carbon, for instance, and I want to know how many neutrons are in carbon. All right, we're going to look at the atomic number, and that's 6. Okay, and we're going to look at the atomic mass. That's 12. Okay, and we're just going to subtract those numbers. Okay, so 12 minus 6 gives you 6. So carbon has 6 neutrons, and that's all there is to it. Okay, we move on to ions. All right, ions are charged particles. Okay, so these are atoms that have gained or lost electrons. Electrons, okay, and that's a little symbol of electrons. Let's go ahead and write these out because I use them often. P plus is your protons. E negative is your electrons. And N with a little 0 at the top is neutrons. Okay, so you all know what kind of symbols I use. There you are. Okay, so ions are atoms that have gained or lost electrons to either become positive or negative. Okay, so we have positive ions and negative ions. Okay, positive ions are called cations. Right, and negative ions are called anions. Anions, there you go. Okay, so if we were to look at a symbol, an ion symbol, let's say we have Li plus, okay? The charge is written at the top right, all right? So, which is different than a subscript, which we'll get into later, but charge is written at top right, okay? A positive charge, okay, means that there are now more protons than electrons, so it means that we have lost electrons. Okay, negative charge. Okay, negative charge means that we have added more electrons and we have overall more electrons than we do protons. So that means we have gained electrons. Okay, it means an electron gain overall. All right, so just some examples. F minus, fluorine with a -1 charge, that is a fluorine cation, or sorry, fluorine anion. Because it's negative. Okay, Al3 plus, and notice it's not +3, it's 3 plus. Put the number, then the symbol. Okay, number, then the symbol. This is aluminum. Okay, and because it is a positive ion, it is a cation. Okay, now this is how you name these. You give the element name, and then you tell whether it's an anion or a cation. Okay, and then O2 minus, again, 2 minus, not -2. Okay, O is oxygen. All right, and because it's negative, it is going to be an anion. Okay, that's ions. Let's move on to isotopes. Covering a lot of ground on this one. Okay, so if ions are basically atoms with differing number of electrons, okay, isotopes are atoms with differing numbers of neutrons. Okay, now, you might ask, we've got ions for different number of electrons, we've got isotopes for different number of neutrons, but what is the name for something that has a different number of protons? Well, anytime you change a proton, you're going to change what the element is. So there's really no, term for something with a different number of neutrons. It's just a different element altogether. Okay, so isotopes, they have different number of protons, but they do have the same number of, they have a different number of neutrons, but they have the same number of protons. Okay, same number. Forgot the word number in there. Same number of protons, because again, we want to talk about the exact same element. Okay. Anytime we have one of these, we're going to name it. We're going to name the element. So let's say silicon, and then we're going to give the mass number. Okay. And the way you find the number of neutrons, okay, so you have the name here and the mass number here. And the way you find the number of neutrons is you're going to take that mass number, just like we did earlier, mass number minus the number of protons, which is atomic number. Okay, and that's going to give you your number of neutrons. So if we were to do this, silicon, okay, silicon 28 is how you would say that. Silicon 28, you're going to have a 28 mass number. You're going to look at the periodic table and find out that its atomic number is 14. And there we have 14 neutrons. Okay, 28 minus 14 is 14. Okay, so another one. Okay, and certain elements have, numbers, high numbers of isotopes. So there's no one number that's more common than others. But let's say we got silicon 27. Okay, and then silicon 26. Okay, so if silicon 28 has 14, 28 minus 14 is 14. Silicon 27, you're going to have 27 minus 14, and you're going to have 13 neutrons. So you're going to have 13 neutrons. Okay, and then 26, obviously, we're going to have 12 neutrons. Okay, again, you have your element name here, and you have your mass number there. Okay, so you say the mass number, or sorry, so you say the name and then you say the mass number. That's just how you say it. If we're talking about symbols, okay, that's how you write it out. If we're talking about symbols, okay, for an isotope, let's say we're going to use silicon 29, okay, as our example. You're going to have Si, because that's the symbol for silicon. You're going to put your mass number on the top left. Okay, that's your mass number. Okay, and then you're going to put your atomic number on the bottom left. Okay, mass number on top, atomic number on the bottom. So if we were to do carbon 12 here, carbon 12, C is the symbol for carbon. We're going to put our mass number on the top left, which is this number right here. Okay, these two numbers correspond. Okay, so you have 12 here, and then you look on the periodic table, you find that the atomic number for carbon is 6, and you put your 6 right there, and that's your symbol. Okay, that is atoms, ions, and isotopes.